Welcome to Vision Plus and welcome back to S.4 Mathematics. We are looking at finding the gradient of a curve at a given point. Example 4 says, find the gradient of a curve at A. The curve is y equals to x cubed plus 5x squared minus 3x plus 2 at the point 1 and 0. So we need to find the gradient of this curve at the point 1 and 0. So for us to get the gradient of the curve at a given point, we need to first get the gradient function of that curve. That means we need to differentiate the given curve. So dy dx equals to, if we differentiate x cubed, we shall get 3x squared plus, if we differentiate 5x squared, we shall get 10x minus, if we differentiate 3x, we get 3 plus, if we differentiate 2, we get 0. 2 is a constant. So this is the gradient function of the curve. This is a function that gives us the gradient of the curve at any point on the curve. So since we have a point on the curve that is at point 1 and 0, what is now the gradient of this curve at this point? So we use the gradient function to define for us what the gradient is at the point 1 and 0. So we simply say dy dx at the point 1 and 0 equals to, this is x, this is y. You come and use the gradient function and substitute for x. X is 1. So here we shall have 3. X is 1 but square plus 10 times 1 minus 3. This here gives us 3 plus 10 minus 3. And therefore, this gives us 10. So the gradient of this curve at the point 1 and 0 is 10. Yes, it is 10. And that is the solution to part A. Let us go to part B. Part B, find the gradient of the curve. The curve is y equals to 3x squared only at the point 2 and 8. So the first thing that we need to do is to find the gradient function of this curve. That means we differentiate. So dy dx equals to, when we differentiate 3x squared, it simply gives us 6x. So this is the gradient function of the curve. This is a function that tells us what the gradient of the curve is at a given point. So at the given point 2 and 8, what is now the gradient? So we substitute. So we say dy dx at the point 2 and 8 equals to, this is x, this is y. So we substitute for x in the gradient function such that we can get the gradient of the curve. So this is 6 times 2. Then you press the calculator and you get 12. Therefore, the gradient of this curve at the point 2 and 8 is 12 simply. And that is the answer. So this is the solution to example 4.